Chapter 1. Java Today, the Modern Platform and Ecosystem. Chapter 1. Java Today, the Modern Platform and Ecosystem, introduces Java as it exists now, not as an old language kept alive by legacy systems, but as a mature, continuously evolving platform for serious back-end platform cloud data and enterprise work. Java matters because it sits in a rare position. It is old enough to be battle-tested, but not frozen in the past. It has decades of production experience behind it, yet the platform has continued to evolve with modern language features, better runtime behavior, improved release discipline, and strong support for cloud-native architecture. That combination is why Java still appears so often in banking, insurance, logistics, telecom, public sector systems, large SaaS platforms, and internal enterprise platforms, where reliability matters more than fashion. The most important thing to understand is that Java is not only a programming language, it is a full platform. The language gives us syntax and modeling tools. The JVM gives us portability, runtime optimization, memory management, observability hooks, and a mature execution environment. The ecosystem gives us frameworks, libraries, build tools, testing tools, operational patterns, and a huge talent pool. When companies choose Java, they are often choosing this whole system, not just the language itself. That is also why Java has remained relevant through several architectural eras. It was used heavily for large monolithic enterprise systems. It adapted well to layered web applications. It became a strong fit for service-oriented systems. It moved into microservices through Spring Boot and similar frameworks. It runs naturally in containers. It can serve APIs, background workers, event consumers, data processors, batch jobs, and platform components. With newer JVM improvements and modern frameworks, it can also be used in more startup-sensitive and cloud-native environments than many people historically expected. A senior engineer should avoid the lazy framing that Java is either legacy or modern. Both can be depending on the code base. A Java 8 application with heavy XML configuration, unclear boundaries, and years of accidental complexity may feel old. A Java 21 service using records, sealed types, virtual threads, structured concurrency, modern testing, strong observability, and clean deployment practices can feel very current. The real question is not whether the language is old. The real question is whether the system uses the platform deliberately. Java's strongest advantage is predictability. The ecosystem has stable conventions. The runtime is well understood. The operational model is mature. Tooling support is excellent. Build systems, dependency management, profiling, debugging, metrics, tracing, and test automation are all mainstream. This makes Java especially valuable in environments where a system must be maintained by many people over many years. In enterprise work, that matters. A clever language feature is useful, but a platform that teams can understand, operate, and hire for is often more important. Java also benefits from strong backward compatibility. Existing investments usually do not become worthless overnight. Libraries, APIs, frameworks, and runtime behavior tend to evolve carefully. This does not mean upgrades are effortless, but it does mean the platform is designed for long-term systems. For organizations with critical applications, this is a major reason to stay with Java or modernize existing Java estates instead of replacing them unnecessarily. Where Java excels is in systems with real operational weight, transaction-heavy applications, integration-heavy backend systems, API platforms, data-intensive services, secure enterprise applications, and long-lived internal platforms are natural Java territory. It is also strong where many teams must collaborate across bounded domains, shared libraries, internal standards, and common operational practices. Java's explicitness and ecosystem maturity often make it easier to keep such systems understandable. Where Java may not be the best fit is very small scripting, throwaway automation, lightweight command line tasks, or situations where startup time and deployment size dominate every other concern. It can still be used there, but it is not always the simplest choice. Senior engineers should choose Java because its platform qualities match the problem, not because it is familiar by default. The practical takeaway is simple. Modern Java is a serious engineering platform. Its value comes from the combination of language, JVM, ecosystem, tooling, release discipline, and production maturity. Used poorly, it can become heavy and bureaucratic. Used well, it gives teams a stable foundation for systems that must scale technically, organizationally, and operationally. For the rest of this course, Java should be viewed through that lens. We are not learning isolated syntax tricks. We are studying how modern Java helps experienced engineers build reliable, maintainable, observable, and evolvable systems. The goal is not to write more Java. The goal is to use the Java platform well.